Since 1865, human impact has caused CO2 emissions to rise from 1,600 to 36,000 million metric tons. This abundance of CO2 in the atmosphere means that nature's carbon cycle cannot cope, and the excess carbon can cause catastrophic environmental effects. Today, the construction industry itself equates to 40% of global energy use and emits a massive amount of carbon into the atmosphere through manufacturing of materials. Within architecture and construction, we hold great responsibility to reduce these figures through our specification and construction. The manufacturing process of Portland cement equates to 5% of the entire embodied energy of a building. This has motivated various companies to further invest into greener concrete types or cement alternatives. This video will briefly look into the processes and challenges faced by companies, all with the same aim. UK-based company Novacem began early development into a more cost-efficient, carbon-negative cement back in 2010. By definition, carbon-negative cement absorbs more carbon dioxide than it emits. The company's proposed cement type would absorb CO2 from the air while hardening. Through a process called carbon sequestration by mineral carbonation, limestone is substituted for magnesium silicates, which contain no traces of CO2 and do not need to be heated at a high temperature. Instead, they are heated at 800 degrees Celsius and converted to magnesium oxide. The cement base is then combined with magnesium carbonates, which become the carbon-negative component. As a result, Novacem cement absorbs up to 100 kg more CO2 than it emits. After receiving worldwide recognition along with the Material of the Year award in 2010, the company lost all of its potential investors and went into liquidation in 2012. Consequently, there was a gap in the market for similar products, plus an accessible body of knowledge that Novacem had published before its termination. This shed a light onto the Halifax-based Carbon Cure and New Jersey-based Solidia Technologies. Introducing new structural materials into the building sector is difficult, costly, and a huge risk if any failures do occur. Cement becomes the binding agent of concrete, so any alternatives hold great responsibility in the structural soundness of a structure. Passing material as safe to use can take a lot of time and money. With this in mind, Carbon Cure continue to use Portland cement, but instead injects carbon dioxide captured from industrial processes into the cement along with water. As a result, the strength of their concrete increases by 10 to 20%. Still in the early development phase, the company primarily produce concrete blocks, which still have a heavy carbon footprint and have a long way to go to differentiate themselves from others. Solidia Technologies use similar methods, however they are backed by larger companies such as Lafarge and may be more promising to follow. Methods of strengthening concrete without removing the Portland cement may be the quicker way forward if we look further at the examples of high-performance concrete or ultra-high-performance concrete, UHPC. Maintaining the existing components of structural concrete, these methods will add different cement proportions, superplasticizers, and reinforced fibers to increase the strength of the concrete. Through testing, the compressive strength and durability of the product are much higher than typical concrete. While the manufacturing processes of each added element are intensive in themselves, the overall increased strength require less of the product to be used, and therefore bring the overall embodied energy figures down. Perhaps the most promising future of UHPC will be finding the optimal balance between increased strength and decreased carbon emissions of the product. Since the 1970s overall, the manufacturing process of Portland cement has improved its energy efficiency significantly, but not nearly enough. While cement makes up only 10% of mass of concrete, it is responsible for 90% of the material's total emissions. At such early stages, there is definitely hesitation to move from a universal concrete formula to new experimental types in theory, but mainly on the construction site. With further research and innovation into cement alternatives or greener concrete, we may start to see results. However, as a nation, we will require rapid advances in technology before these products will reach a meaningful market share.